Good morning, dear students. Today we'll solve the problems on natural response as well as on forced response, which is related to the difference equation. Now you look at the question. Find the natural response of the system described by the difference equation. This is the difference equation, that is y of n minus 1 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 is equal to x of n plus x of n minus 1, and the initial conditions they are given like y of minus 1 is equal to 0 and y of minus 2 is equal to 1. So in the last class or previous class, we have discussed about the natural response, forced response, and the complete response, which is related with the differential equations. In this class, we are going to discuss on natural response and forced response, which is related to difference equations. And this is what the difference equation, what the given is. And next you write the homogeneous equation. So before writing a homogeneous equation, you should keep in mind that your input should be 0 to find the natural response. So that's why I made input as 0. X of n and x of n minus 1, it should be made 0. That's why it is, the equation will be like this: y of n minus 1 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 is equal to 0. Now you write the characteristic equation. So in place of y of n minus 1, you just write r to the power of minus 1, and in place of y of n minus 2, r to the power of minus 2. If it is y of n minus 3, you just write r to the power of minus 3. Y of n, it will be constant, and that will be 1 only. 1 minus 1 by 4 r to the power of minus 1 1 by 8 r to the power of minus 2 is equal to 0. From this equation, you calculate you open up the characteristic equation and calculate the roots. So the roots are like this: r1 is equal to 1 by 2 and r2 is equal to minus 1 by 4, or else you can divide whole equation by the lowest power, that is minus 2. So r to the power of minus 2, if you divide r to the power of minus 2, you will get r square. And if you divide it 1 by 4 into r to the power of minus 1 divided by r to the power of 2, it will be plus 1. And if you divide r to the power of 2 to this equation, that is 1 by 8 r to the power of minus 2 divided by r to the power of 2, r to the power of minus 2 and r square will get cancelled, and remaining will be 1 by 8. And or else using calc, you can calculate directly the characteristic equation or the roots, that is r1 and r2. Here the r1 is 1 by 2 and r2 is minus 1 by 4, and these roots are non-repeated. So if it is repeated, your equation will going to change. That I have explained in the previous class itself. Go through that notes, you will conclude that how the roots can be written. Look at the natural response. So it is in the form of the roots and the coefficient equations. Here you look at this: y of n is equal to n, y of n is equal to c1 r to the power of n plus c2 r to the power of n. The roots and the coefficients. The c1, r1, the value of r1 is 1 by 2 and the value of r2 is minus 1 by 4. That's what I have written here. From equation 1 we get, look at this, here is the equation 1. So you take this equation, or you consider this equation, and open up for y of n. So when you write it for y of n, you just shift it to right side. It will be plus 1 by 4 y of n minus 1 and plus 1 by 8 y of n minus 2. Now using equation 2 and 3, using this equation 2 and 3, the initial conditions get. So they have already mentioned the initial conditions. By using these initial conditions, we can calculate that y of n values. We just put 0 in place of n. So in the first equation, you just take this equation first, 3 equation, put 0. So wherever you get n, you just put 0. So that is y of 0 plus 1 by 4 y of n, you just put 0, you will get minus 1, and plus 1 by 8 y of 0 minus 2, it will be minus 2, and that is equal to 1 by, now you consider this equation 1 by 4. So y of minus 1 so is equal to 0. So y of minus 1 is equal to 0. So that's why it is 0. So 1 by 8, y of minus 2 is 1, so that's why I've written it as 1. So the total will be 1 by 8. 1 by 4 into 0 you will get 0 only, so remaining is 1 by 8. So that 1 by 8 is equal to C1 plus C2. C1 plus C2. Don't get confused. When you're going to when you're going to substitute 0 in n, you'll get C1 into 0 only. That's why I written it as C1 plus C2 into minus 1 by 4 whole to the power of 0, that is 1, that is e to the power of 0 is equal to 1. So that's why C1 plus C2 is equal to 1 by 8. Next you substitute 1. So 1 by 4 y of 1 minus 1 will get 0. Next 1 by 8 y of 1 minus 2 will get minus 1. So next we substitute the values. 1 by 4, that y of 0 you already got the value, that is y of 0 is equal to 1 by 8. The same 1 by 8 you write it here, 1 by 8 plus 1 by 8 y of minus 1 can be written as 0. So this is 0. Now so 1 by 8 into 0 you will get 0 only, and 1 by 4 and 1 by 8 if you multiply you will get 1 by 32, that is equal to 1 by 2. Now you substitute 1 by 2. If you substitute 1 you will get 1 by 2 into C1, that's what I have written here, 1 by 2 C1 minus 1 by 4 C2. Here it is, here minus is there, it will come outside. When you substitute 1 here, it will come outside, that is 1 by 4 minus 1 by 4 C2. And now you calculate the value of C1 and C2 using these two equations. So when you calculate you will get C1 is equal to 1 by 12 and C2 is equal to 1 by 24. We just put it in the main equation, that is the conditional equation, that is y of n, that is the natural response. C1 is 1 by 12 and 1 by 2 whole to the power of n plus C2 is equal to 1 by 24 into 1 by 4 whole to the power of n. This is what the natural response is. Now next we'll study about the forced response. So this is similar to that of the difference equation, but it is related to the with the difference equation. That difference equation again it speaks about the discrete time samples or discrete time signals. We just remember these equations, that is input and particular solution. For constant k, you have to write the particular solution in this form, that is k. For a into alpha to the power of n, we just write k into alpha to the power of n, a into cos omega n plus phi. The particular solution for that is k1 cos omega n plus k2 sin omega n. Now we look into the problems. The problem is like this: determine the zero state response for the system described by the difference equation, that is y of n minus 5 by 6 y of n minus 1 plus 1 by 6 y of n minus 2 is equal to x of n, where the forced function or the forced response or a zero state response is x of n is equal to 2 to the power of n greater than or equal to 0. You just remember this condition, n greater than or equal to 0. It speaks only when n greater than or equal to 0 only, not less than 1, and 0 elsewhere. This is the condition what they are given, and you write it in the proper form, that is y of n. It's given y of n minus 5 by 6 y of n minus 5 by 6 y of n minus 1 plus 1 by 6 y of n minus 2 is equal to x of n. This is the given equation. Now you write in the proper form, that is 1 y of n is equal to, you take out y of n outside, that y of n is equal to 5 by 6 y of n minus 1. This will become minus when it shift towards the right, 1 by 6 y of n minus 2, and this will be plus x of n, because it is already there in the positive side or right hand side. And the formula is like this for forced response, that is y f of n is equal to y of n plus yp of n, that is it's a combination of natural response and particular solution. If you want to calculate the forced response, you just remember it's a combination of natural response as well as the particular solutions. Natural response you have to calculate, and forced response it is dependent on the particular solution. Next, you write the characteristic equation. It is similar to that of the natural response what you written in the natural response form. That is, you just put y of n is equal to 1 and 5 by 6 y of n minus 1 this will be replaced by r to the power of minus 1. Y of n minus 2 is also replaced by r to the power of minus 2. If it is y of n minus 3, then you can write r to the power of minus 3. But in this case, it is not mentioned. That is, y of n minus 3 is not mentioned. That's why we are not going to consider that is y of n minus 3. So we just consider only two conditions, that is y of n minus 1 and y of n minus 2. Next, you calculate the value of r1 and r2. If you are going to calculate r1 and r2, you will get 1 by 3 and 1 by 2. Now you write the natural response form y of n. The roots are different, that you can write c1 r to the power of n. So in place of r, you just write 1 by 3 and plus c2 r2 is 1 by 2 whole to the power of n. This is the natural response. And you look at the particular solution, what is in the that is 2 to the power of n, 2 to the power of n into u of n. That u of n is nothing but 1. Look at this. It is in the form of k into alpha to the power of n. So that k into alpha to the power of n, that's to the power of n into u of n. Now substitute equation 4 in 1. This is the equation number 4. You just put it in equation number 1. That is y of n, that is k into 2 to the power of n into u of n. U of n will be 1 only. U of n is 1, so that's why it is k into 2 to the power of n minus 5 by 6 k into 2 to the power of n minus 1, because it is y of n minus 1, that's why it is n minus 1 plus 1 by 6 k into 2 to the power of n minus 2 is equal to 2 to the power of n. Why it is 2 to the power of n? Because x of n is equal to 2 to the power of n into u of n, but u of n is 1. The value of u of n is 1. That's why we have not written that u of n into 1, or else you can write, if you want, you can write that is 1. Now you take 2 to the power of n as a common in the left hand as well as in the right hand side. If you take 2 to the power of n, those two will get cancelled. Right hand side and left hand side will get cancelled, and remaining will be k minus 5 by 6 k to the power of 2 to the power of k into 2 to the power of minus 1. If you take 2 to the power of n, it will come outside. Here also 2 to the power of n into 2 to the power of minus 2. You just take 2 to the power of n outside, and those 2 to the power of n will get cancelled on both the sides, that is LHS and RHS, and remaining will be 1, and this is what the equation is. Next, we calculate the value of k, it is 8 by 5. Now you substitute in a forced equation, that is, it's a combination of natural response and the particular solution, and here is the natural response equation, that is 1 by 3 whole to the power of n plus c2 1 by 2 whole to the power of n, plus the particular solution is k is 8 by 5 and 2 to the power of n. That's in the form of k into 2 to the power of n into u of n. K, the value of k is 8 by 5 and 2 to the power of n. U of n is 1. This is what the equation is. Next, assume the initial conditions are 0. In this case, they will not going to mention in forced response. They will not going to give the initial conditions. We have to assume the initial conditions. You just assume the initial conditions as y of minus 1 is equal to 0 and y of minus 2 is equal to 0 using equation 2 and 5. So this is the fifth equation, and use the basic equation or given equation, that is equation number 2. Here is the equation number 2. Y of n is equal to 5 by 6 y of n minus 1 minus 1 by 6 y of n minus 2 plus x of n. This is what the equation is. We just put in that equation 2 and 5. Use equation 2 and 5. What I said, y of minus 1 is equal to 0 and y of minus 2 is equal to 0. Just consider 0 and 1. So y of 0 is equal to 5 by 6 plus y of 0 is equal to 5 by 6 y of minus 1. 5 by 6 y of 0 minus 1 will get y of minus 1, and minus 1 by 6 y of 0 minus 2. 0 minus 2 will get minus 2 plus 1, x of n is equal to 1, and you will get, so y of minus 1 is equal to 0, then this will become 0, and y of minus 2 is equal to 0, this will get cancelled, and remaining is 1, that is 1 is equal to c1. If you substitute 0, you will get 0 only, so you get 1, so that's why it is c1 plus c2 plus 2 to the power of 8 by 5 plus 2 to the power of 0 is 1, that's why it is 8 by 5. Now you substitute 1, that when you substitute 1, the main equation, that is 5 by 6 y of 0 plus 1 by 6 y of minus 1 plus 2 is equal to 17 by 16. You just have a look at this, that is y of minus 1 is equal to 0, so this will be 0 only, and y of 0, that will be 1. They are not mentioned for y of 0, that is 5 by 6 into 1 plus 2, so 6 into 2, remaining is 5 by 6 plus 2, so you calculate, you will get 6 2s are 12, 12 plus 5, it is 17, that is 17 by 6. So next you substitute 1 in this equation, that is 1 by 3 c1 plus 1 by 2 c2 plus 16 by 5. Now you calculate the value for c1 and c2, you will get c1 is equal to 2 by 5 and c2 is equal to minus 1. Finally you have to substitute in the main equation, that is this equation. So c1, value of c1 is 2 by 5, 1 by 3 whole to the power of n plus c2 is 2, 1 by 2 plus 8 by 5, and here it is plus 8 by 5 to the power of n. This is what the forced response is. Thank you.